I'd like to talk a bit about how a UVC lamp works. I have one in front of me here, and basically it's a lamp just like the ones you know from home. It needs some power, and then it emits light. That being said, UVC lamps are a bit special because we have a lamp that consists of a tube filled with gas, and then we have an electrode at one end and a cathode at the other end. They work by igniting a spark between them, which heats up the gas, and that's where the light comes from. This also means that if we take a UVC lamp and plug it directly into the socket, it will light up just fine. But because there's nothing controlling its temperature or the way it heats up, it will break down within 14 days to 3 weeks. It will still shine a nice blue, but there won't be any UVC coming out. So what we do in a lamp like this, what I have nicely hidden inside here, is a ballast or a power supply. We call it a ballast because it essentially controls the function of the lamp. That means when I plug this into the socket, I supply power to my ballast, which then lights up the bulb according to what we've designed it to do. And how it lights up the bulb depends on what type of bulb I have and where the bulb is going to be used. The bulb I have right here in front of me is what you call a standard UVC bulb, a mercury lamp. And it's called a mercury lamp because there are 2 to 5 milligrams of mercury inside it. So when my ballast lights up this lamp, we heat up the gas, then the mercury starts to evaporate. And when the mercury has evaporated, I get UVC. When the bulb has been on for a longer period, it reaches its operating temperature, and the ballast ensures that the bulb always burns in the same way. So it basically measures how the bulb is doing, whether the bulb is behaving properly. This also gives me the advantage that if the bulb isn't behaving properly, I can get a signal that warns me that my UVC lamp isn't working. Mercury lamps are excellent for operating in normal environments. In terms of temperature, that's 20 to 30 degrees. If we go outside that temperature range, we start to have a problem where the mercury doesn't actually evaporate properly inside the tube, and then we don't get the UVC we want. That's why we also have the option, if we need to use it at lower temperatures, maybe all the way down to -10 in warmer environments, like production rooms up to 80 to 90 degrees. In that case, we choose a different type of bulb. It's called an amalgam bulb. When we change the bulb, it's also important that we change the ballast, because the bulb and the ballast must always be a perfect match. If they aren't, you risk one of the parts breaking. That's also why every time we set up a new system, we replace all the components in it. When I have a bulb that's sensitive to temperature, as they tend to be, I need to protect them. That's why I use a quartz glass, which is simply a glass enclosure where my bulb is placed inside. This creates a thin layer of air around the bulb, which the bulb heats up. And in this way, I have a local environment that allows my bulb to operate much more stably and efficiently. That's why our bulbs are always placed inside this kind of quartz glass. When you get into certain types of production, it can be a bit of a problem to have too much glass inside, because if the glass breaks, it can end up in food products and the like, and that's not good. In that case, we can take our quartz glass and protect it with a fine film. It's a completely protective film that wraps around and ensures that if this glass breaks, no shards will escape into the environment. When you build these systems up in several stages with different components, it's really, really important that every time you've set up something new, you check what you've done. We check 2 things. The first thing we check is always whether our lamps produce ozone. We are not interested in our lamps producing ozone, since ozone is harmful to humans and animals, and our lamps are often used in places where there are people and animals in the room. For that, we use an ozone meter. The lamp is placed in a box together with our ozone meter for 15 minutes, and there must not be any readings. The next thing is, do we deliver the UVC we expect? UVC is outside the visible spectrum. That's why we have to measure it. And for that purpose, of course, we have some measuring equipment, which we use every time to check our lamps. Do they deliver what we expect them to? And if we want to get really nerdy, we actually test them over their entire lifespan, because the lamps change over time. And it's very, very important to know your lamps. But again, with the right ballast and the right lamp, we actually have stable UVC throughout its entire lifespan.